All right, we're looking at this log now, and thank you very much for submitting. You gave me a full config dump, you gave me the video, you gave me the sync time even, and a description of your setup. So thank you very much for that. That's all helpful information, and hopefully it'll help me do a better analysis. But honestly, there's not a lot of analysis to do here. You're right that it's flying pretty good. And I have to get pretty nitpicky before I start to find anything to criticize. You are running Betaflight 1.10, so very good. And so there's not anything to say about soft filters or anything like that because that's all sort of automatic under Betaflight 10. Your D-term cut hertz is 10, so I would definitely recommend. I don't know why people are doing this. I think it's because people didn't get the message about Betaflight V2 when when gyro cut and P-term cut went away, and D-term cut is now the only thing left. It used to be you'd have D-term cut set lower, but when Boris went to Betaflight V2, he implemented a new kind of soft filter, and that's why gyro cut and P-term cut went away, because it was deemed that those were no longer necessary to tune, that this one value worked so well that it was acceptable just to have the same value for everybody. When that happened, the default value for D-term cut changed, and it's now, I think it's 40. It's either 30 or 40. I can't remember if it's the same for PID controller 1 and 2, or if it's 40 for one and 30 for the other. So having D-term cut at 10, which used to be a little bit low, but a normal acceptable value, having it set to 10 on Betaflight V2 with the FIR or FIR filter is way too low and is hurting your PID loop's ability to make the copter fly good. So definitely, if you set that at 10 just because you remembered that's what you used to have it at, put it back to the default. Anytime the default values change, you should pay attention to that, because sometimes the default values change because, we just refined it a little bit. Like it used to be that on LuxFloat, the default values the P values were a little bit too high. And if you started to, on some setups, you could actually burn the ESCs or the motors. If you had with just the defaults, so the defaults were revised downwards to be a little bit more appropriate for everybody. But sometimes when the defaults change, it's because there's some underlying change to the mechanics, like of the PID algorithm, and the new defaults reflect the new state of normal. And so if you keep your old settings when the underlying mechanics have changed, things aren't going to work right. So the first thing I would suggest you do is you put that back at your default of, I think it's 40, and you see how your copter flies. Most people are not having to tweak that and are finding, and again, this is just from reading what other people are saying all over RC groups and YouTube and stuff. Most people are not having to tweak that, and they're flying fine with the default value. Lowering that cutoff frequency increases the delay of the D term, and that means that the D term is less able to sort of be in sync with and help out the P term. I've used the example in the past of it's like if somebody in front of you opens a swinging door and you try and like slip through the door behind them before the door slams shut, right? Well, if you're too slow, you're going to get the door slammed in your face. And that's what happens when you set your D term cut too low. So in this case, this is too low for most setups under the Betaflight V2 FIR filter paradigm. Okay, so moving past that, I looked at your video. The Blackbox viewer is having a little bit of trouble with your video. I wonder if, I didn't look, but I wonder if since it's a GoPro, it might be 60 frame per second video, and maybe it's stuttering a little bit. So I apologize for that. I'm not going to do a lot of playback because it's stuttering. But if we look at this roll you did here, I did see something here. Let's have a look at it. So there's a little bit of ringing at the end of the roll. We can definitely see that here in your P term, and we can see it here in your gyro as well. And frankly, it's so small that if this was 6 months or a year ago, we wouldn't complain. We wouldn't even notice it. We'd think this copter was flying great. But I think we can do better these days. Flips can be sometimes hard to deal with and to get rid of the bounce at the end of a flip. But rolls they should pretty much be able to be perfect under most of these setups that we've got. And your setup is not it's no slouch, you know. You've got a 2300 kV motor, 22.8, 23, so really beefy motors, 6045 props, plenty beefy props, KISS 30 amp, no complaints there, you know, and so you really ought to be able to get very, very crisp stops at the end of your rolls. So number one thing you can do there is you can put that D term cut back up where it is. The delay that is caused between, and if we look here, in fact, maybe I can even zoom in a little. If we look here, here's the P term, and here's the D term, and it's lagging behind it a little bit. The lower you put the D term cut, the more that D term will be delayed. And so we don't want the D term to be completely overlaid on top of the P term. That wouldn't be ideal. We need it to be lagging a little bit. That's just the nature of the derivative. But we don't want it too much delayed. And when it's too much delayed, it doesn't do as good a job at helping the P term out when without getting into more complicated discussion in math. That's all I'll say about that. So anytime you've got bounce or you've got prop wash oscillation, it may be that the D term is not as effective as it could be because your cutoff is too low. And in this case, that's I think that's quite likely. The other thing I do see also in your setup is that your D gains, let's find them, roll D is only 10. And that's pretty low. I mean, I think most setups will benefit from a D gain of at least about 18 or 20, and many setups will benefit from a D gain even higher, you know, in the maybe the 30s. Now, I don't personally have a ton of experience tuning Lux Float, especially the last time I tuned Lux Float was back on I think 181 or maybe 1.9. So I have no experience tuning Lux Float under the Betaflight paradigm. I tried it out for like a day, kind of didn't feel right, just because I'm not used to it, not because there's anything wrong with it. I went back to PID 1 and just that's where I'm happy and that's where I sit. So I don't know, I don't have as good a sense of what the expected D term values are or D gain values are for LuxFloat, but I'm pretty sure that a D gain of 10 is too low and it's not, the D term's not doing as good a job as it could. So the first thing you should definitely do is fix this value and then fly and see how it goes. But if we look here, and let me zoom back to 100%, we can see that the magnitude of the D term is smaller than the magnitude of the P term. And in many cases, what I've seen is that D does the best job when D is about as big as the P term or maybe a little bigger. Again, a lot has changed in Betaflight V2, so I don't feel as confident about that as I would have under the Betaflight V1, where I had a lot more experience seeing the logs, and that's just the penalty. It's just the price we pay for being on the cutting edge. But it feels to me like your D gain is too low. So if it were me, I would definitely change the D term cut, and I would probably increase my D gain to 15 or 20 just on principle. But if you really want to be methodological about it, then just do one of those things at a time. First, change the cutoff, fly it, see how it flies, and then change the D gain. And we can see here in your gyro, there's this huge overshoot and bounce back even before the oscillation. And this here, look what's happening here. Here, the gyro is positive, so you are now rolling. As the gyro falls off, you're rolling slower. When the gyro hits that zero axis, that's the moment where your copter is stationary, and as the gyro continues to go negative, now it is rolling the other direction, okay? And now it's slowing down and it's coming back, or sorry, it's accelerating, slowing down, and now it's stationary again and it's moving back the other way. But look at this huge overshoot here and then bounce back. This could have to do with the D term being excessively delayed. That if the D term was not so delayed, it would have helped the P term sort of stop on a dime instead of overshooting, bouncing back, etc. Okay, so there's a little bit of analysis there. Another thing I like to look at is I looked for a point in your video where you had relatively high throttle. Here you're at 1751. I don't think there's really any max throttle places here, but 1750 is something. And I'm just going to look at your P term and your gyro. So let's do a custom graph and let's look at PID P. And let's do another graph, which is the gyros. And let's just look at those and see what's happening when you go to high throttle. So here at the top are your three P terms. And I'm going to look for oscillations, sort of bad oscillations. As I always say, there's always going to be some oscillation in the P term. It's never going to be a flat line in a dynamic system like our copter. It could be a flat line if we had a temperature controller on a thermostat on a vat of fluid, which is a relatively stable and static environment. But here in a copter, it's so dynamic that you're never going to really see a flat line. But I'm looking for sort of sharp oscillations, large oscillations, spikes, if you will, and I just am not seeing them. So when you go to high throttle like this and I don't see those hard oscillations, I know that either you've got enough TPA is one possibility, or if you don't have TPA, then your P gains are not too high. So here you've got your TPA breakpoint at 1500 and your TPA at only 10%. So you have very little TPA. So not having a wider perspective on how your copter's flying, I'm not going to say, this with too much confidence. But the fact that even at relatively high throttle, we see these nice docile little P term lines, it makes me think that possibly you could have a little more P gain. Personally, the way I like to see it flying or feel it flying, because you're not going to see the difference. There's say the last 10% of your P gain, you get to like 90% of whatever the top value you could possibly accept as tolerable flying good. And you're not going to see the difference between 90 and 95% and 100%, where 100% is just the absolute highest that you would want the P gain to be. You're not going to see that in the camera, but you're going to feel it in flight, that the copter will feel more sort of locked in or responsive. It'll feel like you're flying in the copter instead of, one step removed. I don't have a better way of putting it than that. It's very much a thing that you feel when you're flying, and it's hard to put into words. But if I look at these P traces, and especially at high throttle or maybe in a prop wash situation, I don't start to see at least a little bit of agitation. If they still look pretty calm, then I think that potentially I would want a little more P gain on there. And you might try it raise one at a time, raise pitch or roll, and see if the copter feels a little more locked in. You could start with roll because I tend to notice it most in turns when I'm trying to set up lines by turning left or right. When I'm trying to gauge my speed by pitching forward and back, I don't think the locked in feel is as important there as it is when you're turning right or left and trying to get, hit a mark. So maybe raise your roll P a little bit and listen and feel for oscillations at high throttle and in prop wash situations, but see if the copter also feels a little bit more locked in. Um, and you can also tweak your yaw. It's both your yaw and your roll P that contribute, I think, the most to that sort of locked in, well-controlled feel that a copter can have. So that's another thing to think about. All right, well, I'm still looking at some other stuff in your trace, and I'm starting to run out of time on this video. So I think I'm actually going to start a second video. Lucky you, lucky me, and talk a little bit more. Okay, so I'll see you there.